Gases, they're everywhere. You can't see them, but you can feel them, like a cool breeze on a summer day. Gases are essential for life. They're in the air we breathe. They're in the fizz of our drinks. They even inflate our car tires. Let's explore the fascinating world of gases and their impact on our daily lives. Think about blowing up a balloon. You fill it with air, which is a mixture of gases. As you blow, you're increasing the pressure inside the balloon. This makes the balloon expand. That's gas in action. Gases are governed by scientific laws. These laws help us understand how gases behave under different conditions. We'll look at 4 important gas laws: Boyle's law, Henry's law, Charles's law, and Gay-Lussac's law. Each law reveals something amazing about the invisible world around us. From the depths of the ocean to the heights of the atmosphere, gases play a vital role. They affect our weather, our transportation, and even our safety. So buckle up. We're about to embark on a journey to uncover the secrets of gases in everyday life. Imagine this: a car accident, a sudden stop. In a fraction of a second, an airbag deploys. It inflates with a whoosh, cushioning the impact for the passengers. This life-saving technology relies on a simple yet powerful principle: Boyle's law. Boyle's law states that the pressure of a gas increases as its volume decreases, assuming a constant temperature. In an airbag, a chemical reaction rapidly produces a large volume of gas. This gas inflates the airbag at lightning speed. The expanding gas creates pressure, pushing the airbag outward. The airbag's volume increases rapidly. This increase in volume causes a decrease in pressure inside the bag. This lower pressure is still enough to cushion the impact, but it's also low enough to prevent serious injury to the passengers. Airbags are a testament to the power of understanding gas laws. They're a remarkable example of how science saves lives every day. Scuba diving, exploring the underwater world. But did you know that breathing underwater requires a different mix of gases than breathing on land? That's where Henry's law comes in. Henry's law states that the amount of gas dissolved in a liquid is proportional to the pressure of the gas above the liquid. In simpler terms, higher pressure means more gas dissolves in the liquid. When a scuba diver descends, the water pressure increases. This increased pressure causes more nitrogen from the air to dissolve in the diver's blood and tissues. As the diver ascends, the pressure decreases. The dissolved nitrogen gradually comes out of solution. If a diver ascends too quickly, the nitrogen forms bubbles in the blood and tissues. This is called decompression sickness, or the bends. It can be extremely painful and even life-threatening. To avoid this, divers carefully monitor their depth and ascent rate. Henry's law reminds us that even the simple act of breathing involves complex interactions between gases and our bodies. It highlights the importance of understanding gas laws for exploring the underwater world safely. Up, up, and away. Weather balloons and Charles's law. Weather balloons, giant balloons soaring high above the earth. They carry instruments to measure temperature, humidity, wind speed, and direction. But how do these balloons stay aloft? The answer lies in Charles's law. Charles's law states that the volume of a gas is directly proportional to its temperature, assuming constant pressure. In other words, as the temperature of a gas increases, its volume also increases. Weather balloons are filled with a lighter-than-air gas, such as helium. As the balloon rises, the atmospheric pressure decreases. This allows the gas inside the balloon to expand. At the same time, the temperature decreases with altitude. This would normally cause the gas to contract. However, the decrease in pressure has a greater effect than the decrease in temperature. Therefore, the gas inside the balloon continues to expand as it rises. This expansion allows the balloon to stay afloat and carry its instruments to high altitudes. Charles's law helps us understand the delicate balance of forces that keeps weather balloons aloft. These balloons provide valuable data for weather forecasting and climate monitoring. Under pressure, Gay-Lussac's law and gas tanks. From propane grills to oxygen tanks in hospitals, compressed gas cylinders are all around us. These tanks store large volumes of gas in a small, manageable space. But how do they do it? The answer lies in Gay-Lussac's law. Gay-Lussac's law states that the pressure of a gas is directly proportional to its temperature, assuming constant volume. In other words, as the temperature of a gas increases, its pressure also increases. Compressed gas cylinders are designed to withstand high pressures. The gas inside the cylinder is stored at a high pressure, but at a relatively low temperature. As the temperature of the gas increases, so does its pressure. This is why it's crucial to store and handle compressed gas cylinders properly. If a cylinder is exposed to excessive heat, the pressure inside can build up to dangerous levels. This could cause the cylinder to rupture or explode. Gay-Lussac's law reminds us that even seemingly harmless objects, like gas cylinders, can pose risks if not handled with care. So the next time you encounter a fizzy drink, inflate a tire, or simply take a breath of air, remember the invisible world of gases at work. These unseen forces shape our lives in countless ways, from the everyday to the extraordinary. Keep exploring, stay curious, and never stop questioning the science that surrounds us.